groundbreaking leap of aviation technology, the legendary F-22 Raptor, already the world's most advanced stealth fighter, has been transformed in ways no one could have anticipated. With 2025 marking a new era of modern warfare, the United States Air Force has unleashed an upgraded version of this iconic war machine, leaving military experts and world governments stunned. What makes the 2025 F-22 so shockingly advanced that global superpowers are scrambling to keep up? Join us as we dive into the shocking innovations that have redefined the F-22 Raptor and left the world in shock. The F-22 Raptor, widely regarded as the most feared aircraft of its kind, first took to the skies in 1997. After being designated the F-22A, it officially entered service on December 2005. From the moment it became fully operational, it dominated the skies with unparalleled features and performance. This cutting-edge fighter jet excelled at taking down enemy aircraft that dared to challenge its supremacy. The F-22 is truly a technological marvel. After a lengthy development process and some early operational challenges, it evolved into a critical asset of the U.S. Air Force's tactical air power. It continues to play a central role in the fighter fleet and will remain a key piece of American air dominance until it is eventually succeeded by the next generation of air superiority fighters. Even today, no other aircraft has managed to surpass the F-22. Its stealth capabilities make it nearly invisible to radar, and its advanced systems allow it to dominate the skies with incredible precision. The F-22 can detect threats from miles away and engage targets with astonishing accuracy. Remarkably, in its history of service, no F-22 has ever been shot down in combat. The development of this advanced aircraft and the upgrades it received have transformed it into a more powerful machine. In 1981, the United States Air Force saw the need to replace older fighter jets like the F-15 Eagle and F-16 Fighting Falcon. This led to the launch of a project called Senior Sky, aimed at creating a next-generation fighter jet that could counter emerging threats from the Soviet Union. These threats included advanced surface-to-air missiles, improved radar systems on Soviet planes, and the development of formidable enemy fighters like the Su-27 and MiG-29. To address these new challenges, the Air Force reached out to aerospace companies, gathering ideas and forming a team to develop cutting-edge technology for this new fighter jet. By 1983, this team became known as the Advanced Tactical Fighter System Program Office, based at Wright-Patterson Air Force Base, which was responsible for overseeing the project. After refining the design and setting performance requirements, the Air Force sought proposals from several major defense companies in September 1985. The main focus of these proposals was to create a fighter jet that could operate stealthily while maintaining high speeds and flying long distances, making it a formidable force in the skies. Over time, the requirements for the new aircraft shifted, placing greater emphasis on stealth technology by December 1985. At the same time, the Navy sought to replace its aging F-14 Tomcat with a new aircraft called the NATF. Since the development of these advanced technologies was incredibly costly, companies were encouraged to collaborate. By October 1986, Lockheed and Northrop were selected as key players. Lockheed formed a partnership with Boeing and General Dynamics, while Northrop teamed up with McDonnell Douglas. For the next 50 months, both teams worked on developing two prototype planes, the YF-22 and YF-23. These aircraft weren't designed for direct competition, but rather to prove that their concepts could function as intended. In parallel, the Air Force brought in Pratt & Whitney and General Electric to create engines for the new planes. During the development process, Lockheed's team made a significant redesign of their aircraft in 1987 to make it lighter. They used cutting-edge tools like computer simulations and wind tunnel tests to ensure the plane met all requirements. To reduce costs, they also made adjustments, such as removing some radar systems and simplifying the ejection seats. Both teams produced two prototypes, each fitted with a different engine to test the options. The YF-22 had its first flight in September 1990, and during testing, it proved it could reach high speeds without needing afterburners. After thorough evaluations, the U.S. Air Force selected Lockheed's design in April 1991. Although the competing YF-23 was faster and more stealthy, the YF-22 stood out for its superior maneuverability and lower production risks. Additionally, it was more cost-effective and easier to manufacture. While the Navy canceled its NATF program due to high costs, the Air Force moved forward with Lockheed's design, which eventually became the F-22 Raptor. The Raptor is now recognized as one of the most advanced fighter jets in the world, after rigorous testing and large-scale exercises to ensure mission readiness. The F-22 was first used in a Homeland Defense mission in January 2007 as part of Operation Noble Eagle. Later that year in November 2007, several F-22 from the 90th Fighter Squadron at Elmendorf Air Force Base in Alaska intercepted two Russian Tu-95 MS bombers under the North American Aerospace Defense Command. Since then, F-22 has frequently escorted Russian Tu-160 bombers during similar encounters. On February 2007, the F-22 was deployed overseas for the first time when the 27th Fighter Squadron was sent to Kadena Air Base in Okinawa, Japan. The initial deployment of the F-22 Raptors encountered significant challenges. As 6 F-22 were flying from Hickam Air Force Base in Hawaii, they experienced multiple system failures due to software issues while crossing the international date line. This forced them to turn back to Hawaii with the help of tanker aircraft providing support. Fortunately, the problem was quickly addressed, and within just 48 hours, the F-22 were back on track, continuing their journey. Kadena Air Base soon became a key rotation point for F-22 units, where they also participated in training exercises in South Korea and Malaysia. These exercises were designed to improve deployment speed and readiness in the event of a conflict with powerful adversaries. To further streamline operations, the U.S. Air Force developed a strategy called Rapid Raptor. This concept allowed for the deployment of 2 to 4 F-22s along with a C-17 aircraft for logistical support, enabling swift, small-scale deployments. The Rapid Raptor concept was first tested at Wake Island in 2013 and later in 2014 in Guam. Additional trials took place in Europe during August and September of 2015, in direct response to Russia's annexation of Crimea in 2014. Building on the success of Rapid Raptor, the U.S. Air Force developed a new operational concept known as Agile Combat Employment. This approach focuses on more flexible and distributed air operations, which are crucial during conflicts with major adversaries, ensuring the Air Force can adapt and respond quickly in high-stakes situations. The F-22 Raptor, also known by its internal designation Configuration 647, is a cutting-edge next-generation fighter jet. What sets it apart isn't just its advanced engineering, but also its revolutionary capabilities. It was the first aircraft to feature supercruise, a game-changing technology that allows it to fly at supersonic speeds without the need for afterburners. This gives it a massive edge in combat, allowing for rapid engagement while conserving fuel. The Raptor combines multiple key features into a single platform: super maneuverability, advanced stealth, and state-of-the-art avionics. These allow it to operate effectively even in hostile environments filled with advanced enemy defenses. Its design is optimized for stealth, featuring a sleek fuselage and uniquely shaped wings with smooth, angled edges. This careful shaping, along with its stealth technology, minimizes its radar signature, making it nearly invisible to enemy detection systems. Unlike older jets, the F-22 has sophisticated control surfaces like flaps, ailerons, and rudders, which give it unmatched agility, even at high speeds. Another stealth-enhancing feature is its internal weapons bays, which keep its arsenal hidden from radar detection until the moment they're needed. In addition to these combat advantages, the F-22 is equipped with practical features like retractable landing gear, a refueling boom for extended missions, and an emergency tailhook for landing in extreme situations. The F-22 Raptor is powered by two advanced Pratt & Whitney F119 turbofan engines, which are positioned close to each other. These engines feature special exhaust nozzles that can tilt up and down to help steer the aircraft. Each engine is equipped with a computerized control system, ensuring optimal performance. These engines generate tremendous thrust, giving the Raptor exceptional maneuverability, even when fully equipped for combat. This balance between power and weight allows the jet to remain highly agile. With its specially designed air intakes, the F-22 can fly at impressive speeds, reaching around Mach 1.8 without the need for extra fuel. When afterburners are engaged, they can exceed speeds of Mach 2. One of the Raptor's unique features is its ability to maintain supersonic flight without afterburners. something that sets it apart from most other fighter jets, which rely on afterburners to reach such speeds. Flying at these high speeds and altitudes also enhances the effectiveness of the Raptor's sensors and weapons, while making it more difficult for ground-based missiles to target. Additionally, the F-22 weapons are stored internally, which reduces drag and allows it to fly even faster than other jets that carry weapons externally. The fighter jet can soar at an impressive speed of Mach 1.2 at an altitude of 52,000 feet, allowing it to cover greater distances with its air-to-air missiles and bombs compared to the older aircraft previously used by the United States Air Force. Its design incorporates robust materials like titanium and advanced composites, enabling it to withstand the intense pressures of supersonic flight. What truly sets the Raptor apart from other fighter jets is its exceptional stealth capabilities. It has been meticulously engineered to evade radar detection, primarily by shaping its body in a way that scatters or absorbs radar waves. To maintain its stealth, the Raptor conceals its weapons inside the fuselage and utilizes specialized materials that further absorb radar signals. Additionally, this remarkable fighter emits minimal radio waves, heat, and noise, making it more challenging for adversaries to locate. However, determining how effective its stealth features are can be complex. While it excels against specific types of radar used by other aircraft, it can be more easily detected by lower-frequency radars, such as those used in weather monitoring or early warning systems, largely due to its size. Radar technology is not infallible. It often struggles with accuracy and can be thrown off by competing signals. Even when a stealth aircraft is detected, it's challenging for defenders to track and engage it effectively. These advanced planes are equipped with sophisticated systems that gather data from various sensors, helping pilots grasp their surroundings better and enhancing their flying capabilities. Key systems include the electronic warfare system, which disrupts enemy communications, the missile launch detector, alerting pilots to incoming threats, the radar communication system for relaying information, the navigation system for precise movement, and an infrared sensor that can spot distant objects. One standout feature is the APG-77 radar installed on the F-22. This radar is remarkable because it can monitor multiple targets simultaneously, regardless of weather conditions. It can also emit signals designed to confuse enemy radar systems, rapidly altering its signals to evade detection. This radar can identify targets from 125 to 150 miles away, and even farther with narrow beams. Additionally, an upgraded version of this radar can create ground maps, track moving targets, and assist in coordinating airstrikes. Alongside the radar, the aircraft is equipped with the ALR-94 electronic warfare system, renowned as one of the most advanced systems on board. The aircraft is equipped with over 30 antennas strategically placed across its structure, allowing it to detect potential threats from every direction. This advanced system can identify targets that are even farther away than the radar can, providing the pilot with critical information to lock onto these targets effectively. Depending on the level of threat detected, the system can advise the pilot to deploy countermeasures, such as flares or chaff, to confuse and mislead enemy missiles. In addition to its impressive radar capabilities, the fighter boasts several other sensors. One of these is the multi-mode laser detector, which can pick up infrared signals from all angles. Another vital component is the advanced infrared search and track sensor mounted on the wing, which can identify and engage distant objects with remarkable accuracy. Inside the cockpit, the Raptor features a state-of-the-art digital flight control system. The primary display is a head-up display that keeps vital flight information within the pilot's line of sight, while 6 additional color screens provide more detailed data and insights. The controls consist of a side stick for maneuvering and throttle levers for speed adjustments. Initially, the Air Force considered using voice commands for controlling the aircraft, but this idea was deemed too risky and ultimately discarded. The cockpit canopy is both large and robust, having undergone a redesign to enhance its durability, as the original version did not meet longevity expectations. The aircraft's radio systems are seamlessly integrated into the controls, allowing for easy communication and navigation input via a keypad. Additionally, there are small displays strategically positioned to provide critical warnings and flight information, ensuring the pilot remains informed throughout the mission. The F-22 Raptor is equipped with an advanced main display that plays a crucial role in navigation. Alongside this, there are additional screens that provide tactical information and help manage weapon systems to maintain stealth during operations. Its communication system is designed to send signals only in specific directions, ensuring secure and targeted communication. When F-22 needs to communicate with each other, they use a unique data link that enhances coordination. Additionally, the aircraft features an automatic system that helps prevent crashes by detecting obstacles and terrain. For pilot safety, the F-22 includes a standard ejection seat similar to those found in many Air Force jets, with a special control mechanism located in the center for easy ejection in emergencies. To ensure the pilot's survival in challenging conditions, the F-22 has a sophisticated life support system. This system generates oxygen on board and includes specialized clothing that offers protection against various threats. It also has a valve that regulates airflow to the pilot's mask and gear, helping to manage G-forces and maintain proper pressure during flight. The pilot's clothing is designed to shield them from chemicals, cold water, and extreme temperatures. After some incidents where pilots experienced low oxygen levels, the system was improved significantly. Now it features a backup oxygen supply and a new valve integrated into the pilot's vest, ensuring their safety even in combat situations. The ejection seat of the fighter jet is designed for survival and comes equipped with a modified M4 carbine. This aircraft cleverly conceals 3 compartments for weapons, a large one located beneath the fuselage, and 2 smaller ones on the sides near the engines. Additionally, there are tiny compartments for countermeasures, like flares, situated behind the side compartments. The spacious central compartment can accommodate up to 6 launchers for long-range missiles, while each side compartment is fitted with 1 launcher for short-range missiles. The primary missiles used by this fighter are the AIM-120 AMRAAM and the AIM-9 Sidewinder, with plans to include the AIM-260 JATM in the future. When it's time to launch a missile, the compartments open rapidly, and mechanical arms swiftly push the missiles out. This quick action helps the jet remain undetected and allows for missile deployment even during high-speed maneuvers. Additionally, there's a hidden 20mm cannon concealed in the right wing of the plane. The firing path of this cannon is displayed on the pilot's screen, ensuring precision targeting. While the main compartment is mainly intended for missiles, it can also hold bombs, allowing the aircraft to carry a total weight of up to 2,000 pounds. Although it can transport GPS-guided bombs, it cannot guide laser-targeted weapons independently. Generally, the fighter jet carries its weapons inside, maintaining a sleek and stealthy profile. The F-22 fighter jet has 4 strong mounting points on its wings, each capable of holding up to 5,000 pounds. These points are designed to carry various attachments, such as fuel tanks or missile launchers. The 2 inner points are specifically made for fuel tanks, while the 2 outer ones now hold special pods that support the plane's advanced systems. If necessary, the aircraft can release the external fuel tanks to maintain its stealth and performance. To ensure the F-22 operates effectively, it undergoes maintenance every 300 hours of flight, a process that takes about 3 weeks to complete. The stealth coatings used on the jet are more advanced than those on older stealth aircraft, but they faced challenges when the jets were deployed to Guam in 2009. The coatings struggled to withstand the rain and moisture, which affected their durability. Maintaining the F-22's stealth capabilities requires significant time and attention, especially for its coatings. To address this, efforts are underway to develop stronger and more resilient coatings. The major maintenance work for the F-22 takes place at the Ogden Air Logistics Complex, located at Hill Air Force Base in Utah. Because there are limited numbers of these jets in service, extreme care must be taken during maintenance. There is no backup if something goes wrong during the process, so the technicians must be careful to ensure the aircraft remains in top condition. In 2015, the F-22 Raptors were ready for missions 63% of the time, a significant improvement from just 40% when they were first introduced in 2005. The amount of maintenance required for each hour of flight has also dramatically decreased, from 30 hours in 2005 to just 10.5 hours by 2009. This is a big drop from the previous average of 12 hours. Interestingly, in 2014, maintenance workers logged an average of 43 hours for every hour the F-22 was in the air. Initially, the F-22 required maintenance every 1.7 hours of flight, which was better than the 3 hours expected initially. However, by 2012, that maintenance time had risen to 32 hours. As of the fiscal year 2015, the operational cost for each hour of flight reached $59.6 billion. But the F-22's design is not static. It has recently undergone a series of enhancements aimed at improving its capabilities. In Dayton, Ohio, the U.S. Air Force and Lockheed Martin have launched the second phase of annual updates for the F-22 fleet. These updates will include software improvements and quick upgrades, setting a new standard for how future aircraft maintenance will be handled. Even so, the Air Force plans to retire the F-22 once the highly classified next-generation air dominance platform is ready to take its place. The U.S. Air Force invests heavily in keeping its aircraft current and effective. For fiscal year 2025, the Air Force has allocated a substantial budget of $3.5 billion for research, development, testing, and evaluation of its fleet. Over the next 5 years, they plan to spend an impressive $19.5 billion. Dale White, the Program Executive Officer for Fighters and Advanced Aircraft at the Air Force Lifecycle Management Center, emphasized that these investments are crucial for ensuring the F-22 can address both present and future threats. He also shared with reporters that the advancements made for the F-22 will pave the way for the development of future technologies, including the next-generation air dominance program. After completing a significant upgrade on the F-22, known as Increment 3.2B, between 2020 and 2021, Lockheed Martin, in collaboration with the Air Force, has turned its attention to a new initiative called the Raptor Agile Capable Release Program. The first phase of this program was completed in 2022 and focused on enhancing the jet's hardware, enabling it to transmit Link 16 data, which is vital for effective communication and coordination in modern combat scenarios. The second phase of the F-22 upgrade program, known as Ray 2, is a software improvement that has just been approved and is currently being implemented. Following this, the third phase, called Release 3, is expected to roll out in about 12 to 18 months. Meanwhile, the U.S. Air Force and Lockheed Martin are working on enhancing the F-22's range by testing low-drag fuel tanks and pylons, but these upgrades will only start after the completion of the second phase, which includes the RACA Release 2 installation. These upgrades are being conducted under the Advanced Raptor Enhancement and Sustainment Contract, valued at $10.9 billion. A significant milestone occurred on February 4, 2023, when an F-22 from the 1st Fighter Wing successfully shot down a suspected Chinese spy balloon off the coast of South Carolina. This occurred at an altitude of around 60,000 to 65,000 feet, marking the F-22's first confirmed air-to-air kill. The wreckage fell approximately 6 miles offshore and was later recovered by U.S. Navy and U.S. Coast Guard vessels. This program represents an important step in modernizing the F-22, making it more capable of future challenges. On February 10, F-22 fighter jets took down high-altitude objects near Alaska's coast, followed by another incident over Yukon on February 11. The U.S. Air Force plans to begin phasing out the F-22 by the 2030s, as it is set to be replaced by the next-generation air dominance crewed fighter. On May 2021, Air Force Chief of Staff Charles Q. Brown Jr. discussed plans for streamlining the number of fighter fleets, envisioning what he called a 4+1 approach. This would consist of the NGAD replacing the F-22, along with the F-35A, the F-15E, and the F-16. The A-10, originally part of the plan, will be retired earlier than expected and removed from this lineup. The NGAD fighter, short for Next Generation Air Dominance, represents the core of an advanced military technology program designed to ensure U.S. air superiority. This high-tech program is not just limited to the NGAD fighter, but also includes cutting-edge sensors, weapons, unmanned aerial vehicles, propulsion systems, stealth technology, and more. Like the Raptor, the NGAD will be packed with groundbreaking features, particularly in stealth technology, which has only been utilized for one generation of fighters so far. According to the Air Force, the upcoming NGAD fighter will surpass the stealth capabilities of the current F-22 Raptor by introducing a cutting-edge triangular design without vertical stabilizers. This marks the first time in aviation history that a fighter jet will be unveiled with such a groundbreaking design. Previously, vertical stabilizers were essential for keeping planes stable in flight. Until the development of active flow control, which was first seen in the B-2 Spirit. This feature made the B-2 Spirit the stealthiest aircraft ever created. The NGAD fighter will take stealth to a new level, equipped with advanced sensors designed to detect threats long before they can detect the NGAD. These sensors will be so sensitive that they can identify threats from miles away. Instead of traditional externally mounted sensors, the NGAD will use smart skins that are seamlessly integrated into the aircraft's body, allowing for maximum detection capability. This data will not only protect the NGAD, but can also be shared in real time with other friendly units, ensuring the entire fleet stays updated on the battlefield situation. When it comes to firepower, the NGAD will be equipped with America's most lethal weaponry, including guns that can fire massive bullets, bombs, missiles, and possibly even laser weapons. Additionally, it will be supported by loyal wingmen, autonomous drones that can carry out dangerous missions, keeping the main fighter out of harm's way. With the NGAD's unmatched capabilities, the United States could secure its air dominance well into the future. This marks a monumental shift from the current 5th-generation Raptor to the 6th-generation NGAD, a leap that could solidify America's position as the world's leading air power. In the 2025 budget request, the NGAD program also includes upgrades such as Mode 5 Identification Friend or Foe, the Link 16 Communication System, and the Multifunctional Information Distribution System, Joint Tactical Radio System. Other advancements include radar electronic protection, an embedded GPS inertial navigation system modernization, and a new software architecture called GRACE. A new helmet is being tested under the next-generation fixed-wing helmet program, which will replace the 40-year-old HGU-55P headgear. This helmet will feature line-of-sight displays that help pilots aim weapons and reduce their workload, further enhancing their combat effectiveness. Thank you for watching another episode on our channel. While you are still here, click the video on your screen to see more mind-blowing videos like this one.